Welcome back, ladies and gentlemen. We're moving on to 2.5, which is going to be writing equations of lines. We're going to call this part 1. There will be a part 2 later. We're going to write the equation of a line in slope-intercept form based on the line's slope and a point on the line, or the graph of the equation. Okay, now of course slope-intercept form, okay, we've worked with this a little bit, but that's going to be y equals good old mx plus b. Okay, now this is the final answers for this lesson. Short and sweet, there it is. Alright, now for slope-intercept form, we need to talk about point-slope form a little bit. Now, for any line with a slope of m that passes through the point x1, y1, its equation can be written as the following. Alright, now this is going to be y minus y1 equals m parentheses x minus x of 1. Okay, now the y and the x here without subscripts on them are just still going to be the letters x and y. The x1 and the y1 are the coordinates of a point, so those are actually going to be numbers. And then the m is the slope as well, so that's going to be a number that we're going to plug in as well. So basically there's 5 letters here, and we're going to plug 3 numbers in to 3 of those letters. Alright, but in general, this equation is used as a tool to get to the more familiar slope-intercept form of the equation. So again, that thing is a useful formula, but we're just going to use it as a tool to get to a nicer looking answer. Alright, now if we're going to be writing the equation of a line based on the slope and a point on the line, here's what it's going to look like. Okay, what's the equation of a line with a slope of -2 that passes through the point 4, 1? Alright, now as I said in that last slide, okay, we're going to need to use our point-slope form as a tool. And again, it's point-slope form because it contains both a point and the slope. Again, mathematicians, we're very unimaginative. Okay, so there's the form we're going to plug into. Okay, now again, the slope of -2, that basically tells me that my m is -2. Okay, and again, that 4, 1, I'll write it over here off to the side just to kind of clarify things. Okay, just like when we were doing the slope form before, the 4, 1 consists of an x1 and a y1. Now we don't have a second point here to call x2 and y2, but that's what we have. And so again, we're going to plug these numbers into this form and basically just clean it up. Okay, so again, like I said in the previous slide, that y is still going to be a y. I'm not going to replace the letter that doesn't have a subscript. Okay, now this guy that does have a subscript, the y1, is in this case coincidentally a 1. And then the m is of course the -2 that we've got over there. Okay, I've got a parenthesis. That parenthesis is important. Okay, and I got my x minus the x1 in this case, which is a 4. Okay, now that may look a little bit messy, but we just have a little cleanup duty, and we can get this guy cleaned up and make it look a little nicer. Okay, so for instance, right here we got this -2 that we can go ahead and distribute. So we're going to do that. So I've got the -2x now, and be careful of your signs here. The -2 hits the -4 and gives us a positive 8. Okay, the y minus 1 I'm just going to bring down for now. Okay, and again, the slope-intercept form is y equals mx plus b. So basically I want the y by itself, so I need to get rid of this -1. We don't like him, we want to get rid of him. Okay, now our regular equation solving stuff says, hey, if I'm going to cancel a -1, I use a +1. And of course I want to do it to both sides. Again, notice I'm lining up the like terms. So we do that, cancels out these guys, leaving us with the y, which is what we want. Okay, I've got this -2x that didn't have anybody to get together with, so he's just a -2x. The 8 and the 1 that get together, and make a 9. And there you go, now I've got my slope-intercept form. Okay, and again, we know the slope-intercept form is very handy for graphing, or honestly, if I know what x is, it's pretty easy to plug the x in and figure out what y is based off that equation. Okay, I'd like to do another example of this just to help drive the point home of what we're doing, and hopefully get you to not freak out if you see a fraction right here. Okay, that being said, okay, if my slope is 1/3, of course that means my m is 1/3. And if I'm going through the point 6, -2, that means my 6 is my x1 and my -2 is my y1. Okay, and again, I'm not going to need you to rewrite this formula every time, but for notes purposes and quite honestly I want you to have it memorized, I'm going to write it again. Okay, here's our point-slope form again, because we're putting in a point and the slope, so it's point-slope form. Very exciting. Alright, so y minus the y1. y1 in this case is -2, so again, just because there's a minus sign there doesn't mean I don't need the one that's on the 2. So it's y minus -2. Of course, we'll clean that up in a minute, but let's keep plugging stuff in. I got m is 1/3, so the 1/3 goes where the m is. Again, the very important parenthesis starts. X minus, the x in this case is a 6. And I got something I can distribute and kind of clean up. And don't freak out, you can distribute fractions, it works just fine. 1/3 times x, well, that's honestly kind of easy because you just slap the 1/3 next to the x and you're done. Okay, the 1/3 times 6, okay, if you're not sure, plug that in the calculator, of course, but I'd love for you to look at 1/3 times 6 and think, oh, that's just 2. Alright, and then I've got the y, and of course minus a negative, kind of a leave change sort of thing, and that becomes a plus 2. Alright, so again, I've got my equation almost in the form I want, but again, I want the y by itself, so I need to get rid of this positive 2. Of course, I'll do that by subtracting 2. And as soon as I clean this mess up, as those cancel, the y by itself equals a nice pretty 1/3 x. Negative 2 minus 2 is negative 4. And so again, there's an equation that will be very, very easy to graph, or very easy to plug numbers into if that's what I was trying to do. Alright, now just with most of the graphing things we've done, we've got our two unusual cases that keep cropping up, and here's the first one. Okay, we've got our slope of 0, so again, if you don't like the word slope, use m. M is 0, and the line passes through 2, 4. Again, there's my x1 and my y1. Okay, so here I've got numbers for the things I want numbers for. It's just that one of them is a 0, so that is a little bit weird, but I can still keep using my y minus y1 equals m x minus x1. Okay, just plugging things in. Y minus the y1, in this case, is negative 4. Again, notice we have a minus a negative, so we're going to have to clean that up. The m is 0, and then I've got x minus my x1, which happens to be a 2. Alright. Minus a negative gives me a y plus 4, and then here's the funny thing that happens about this one. As I distribute a 0, well, what's 0 times anything? Hopefully you thought 0. Okay, so basically this 0 gives me a 0x and then a 0. Well, if I have 0x's, I really still have 0, so ultimately the long and the short of it is here, this 0 basically kills off the whole side because it's being multiplied by the whole side. So really I just have a big fat 0 right there. Alright, and then from there, same basic thing applies. I want the y by itself, so I subtract the 4 from both sides, and I've got y equals, and these are like terms, so I just plain old get y equals negative 4. Alright, and if you remember our graphing kind of stuff, this is just simply a horizontal line, and if you remember the slope stuff, that should be no surprise because slope of 0 is always a horizontal line. Okay, the more of that stuff you can keep in your head, the more of this other stuff is going to make sense, so hopefully you can do that. Alright, our next example has m being undefined and the line passing through the point 2, 6. Okay, now again, this is kind of weird. M is undefined. That's not a number, that's a word. Okay, now the line passes through 2, 6, so still that's x1 and y1, so maybe it doesn't seem too weird, but again, if I start thinking about my formula, y minus y1 equals m x minus x1. Alright, well, y minus the y1 is 6 equals, x minus 2. Okay, now here's the problem. Undefined. I'm fairly certain you've never seen that as an equation, or at least definitely not an equation you could do anything with. Okay, and that's the problem. You can't plug in a word. Okay, so basically what you have to do here is kind of have your brain go, hey, undefined slope gives me a vertical line. Okay, and the second thing you have to get past that is any vertical line, or let's say a vertical line's equation, is always x equals some number. Alright, so since a word is not something I can plug into an equation, I have to be able to kind of capitalize on what I know about slope and graphing, that sort of stuff, and be able to say, okay, I got a vertical line always looks like x equals a number, and so it's going to be x equals, okay, now basically I have two choices. I have the x value and the y value. Well, hint, if it's x equals a number, it's going to be the x value. So in this case, this guy is x equals 2, but what's so weird about this, again, like we just said, is you can't plug a word in. So you do have to recognize as soon as you have undefined that you're looking at the exception again. And then, of course, use the x value because you're saying x equals. And there's your equation for this one. So be very careful this one because you can't use the formula. Well, since we've been talking about graphing, maybe it's worth our time to see how this plays out visually. Alright, so what's the equation of a line with a slope of negative 2 that passes through the point 4, 1? Well, since this is our first example, we know the answer is going to be y equals negative 2x plus 9. We already did that. Okay, but if we play with this thing on the graph, maybe that'll make a little more sense. Okay, now my slope's negative 2. Now again, slope just tells me how steep a line is. It doesn't tell me where the line is. So what I need to use now is this 4, 1. So if I just plot this guy, 4, 1 puts me right here. Okay, and now my slope is negative 2. So from this point, I can do my rise over run and go down 2 over 1. Okay, there is nothing that says that my first point that I plot has to be on the y-axis, although it's very convenient, and that's what we do most of the time. But my slope of negative 2, now notice if I keep going down 2, right 1, 2, down 2, right 1, I get further away from the y-axis. And the y-axis is important, so that's where I want to get. So I'm going to go the other direction, so I'm going to go up 2, left 1. So it puts me right there. Up 2, left 1 puts me right there. And as I keep doing this, take a wild guess at where I land when I hit the x-axis. Right, or sorry, the y-axis. Yep, right at 9. Okay, so if I've got this picture right here, okay, hopefully it's not too much of a stretch to say, hey, this is the equation, because my y-intercept is 9, and again, my slope is negative 2. Okay, so again, I've got my y equals mx plus b, just with the appropriate numbers plugged in right there. Okay, now if you can follow that, hopefully we can do the next example without too many worries. Alright, so here we go. We're writing the equation based on the graph of the line. So I've got a picture, and I'm going to come up with the equation just from the picture. So what's the equation line pictured below? Well, again, we're shooting for something that looks like y equals mx plus b. So again, I want to figure out what the m is, and I want to figure out what the b is. Okay, and more or less we can just pull that straight off the graph. Alright, well, let's do the m first because it's listed first. Okay, again, remember m is rise over run. Okay, so all I need to do is pick any 2 points and then calculate my slope. Just for convenience, I'm going to pick these 2 here on the right, and I'm going to start here. And from this point, I go up 2, so there's a positive 2. And then from there, I turn and go 1, 2, 3 over, so there's 3. Okay, notice it's a positive 2 and a positive 3. So in this case, my rise over run is a positive 2 over a positive 3. Okay, remember, if I'd have gone the other way, for example, if I'd have gone this way, it would have been down 2, but then that would have had me going left 3, and then the m in this case would be negative 2 over negative 3, but those negatives cancel out and still give me a positive 2/3. Okay, moral of the story is if you can clean up the slope that you calculate off the graph, please do. Alright, moving on. Alright, then the b, again, is the y-intercept. So I just have to basically look up and down the y-axis and find where I hit. And in this case, I hit right there at 4. Okay, so now basically I just have to throw these 2 numbers into my equation. So I've got y equals, the m we found was 2/3. Put the x right next to that guy, and then I put plus b. Okay, again, remember if the b ends up being negative, I'd put a minus sign here, but since it was positive, I'm going to put a plus 4. Okay, and there you go. There's your equation of that line, and really all you had to do is pull the information right off the graph. Alright, well, I think a legitimate question is, what if the line does not have a nice y-intercept? I mean, we can look at this guy and think, it's about 3 point, I don't know, something. But, I don't want us guessing at this. I want us to be able to figure it out for real. So, let's do that. Okay, so, well, one thing I can get off the graph is the slope. We just did that in the last example. So again, I'm going to pick any 2 points, and let's pick the 2 on the left this time, just to be different. Okay, so I'm going to go from here to here, which is down 2, and then I'm going to work my way over to the right, which looks to be like a positive 5. Okay, so now my slope is negative 2 over 5. Alright, and then here's where the problem sets in. Okay, I don't have a good b value, but what I do have is a whole bunch of points. So what I can do, and you're going to love this, is I need to just pick any one of the points that I have. Okay, now for argument's sake, I'm just going to pick this one right here. Okay, now the coordinates of this point are 2, 3. Okay, so now basically what I have is I have the slope negative 2/5, and I have a point 2, 3. Alright. So, if I only had a formula that dealt with the point and the slope. Oh yeah, I do. It's called point-slope form. So y minus y1 equals mx minus x1. Okay, so unfortunately the information I wanted wasn't staring me in the face, so I can resort to something else that I can use to get the job done. Alright, so now y minus 3 equals negative 2/5, and that's going to be x minus the x1 in this case is a 2. And again, we just got to clean this up. Okay, now we do have this negative fraction, so that is a little bit messy, but we can deal. So y minus 3, okay, I'm going to distribute my negative 2/5 to the x, which of course is very, very nice, because you don't have to really do anything. but now I have the negative 2/5 times the negative 2, and depending on what you want to do, okay, as I distribute that, the negative hits a negative, makes a positive. Okay, and then I've got 2/5 times 2. Now, depending again on your personal preference, you can either get a fraction for that or a decimal, but it definitely doesn't come out even. I'm guessing most of you are going to prefer a decimal, so that's what I'll use right now. Okay, this becomes actually 4/5, which as a decimal is 0.8. Alrighty, so at this point, just like previously, I'm going to add 3 to both sides in order to cancel out this 3 and get the y by itself. So now I've got a negative 2/5 x, and then I've got plus 3.8. Okay, now hopefully that makes a little bit of sense, because again, we looked at this earlier and thought, yeah, it's almost a 4, so it's 3 point something, and I think 3.8 looks pretty darn reasonable. And here are the odd cases again. Alright, well, first of all, I got a horizontal line. Now again, if you remember the equation of a horizontal line, what it looks like, this should be very, very simple. Okay, but I'll just pretend for a second you're like, oh, I forget. Alright, so anyway, we can do what we did before, though. Okay, now this one's nice because I do see my y-intercept. So I know that my b value is, in this case, a 5. Okay, also, because I've got a few points on a graph here, I can calculate my slope. So now my slope is, okay, just pick whichever point. I usually like to start on the left and work my way to the right, so I'll start here. So my rise, notice I don't go anywhere, so my rise is 0, and then my run is going to be 1. And 0 over 1, well, that's just a fancy way to say 0. Okay, so my slope is 0, and my b, my y-intercept is 5, so I can plug those into y equals mx plus b, because that's the information I have. So I've got y equals 0x plus 5. Okay, but again, having 0x is just like having 0. So really what I have is y equals 0 plus 5, and I'm pretty sure 0 plus 5 is 5. And again, if you remember what the equation of a horizontal line looks like, you might have just thought that right off the bat, and not had to go through any of that work, and just went straight to the answer. But if you had to go through the work, no big deal. You just got the same answer anyway. Okay, that being said, now we got a vertical line over here. Okay. Now again, what we can try to do is figure this thing out like we just did the previous guy. Okay, now notice that we don't have a b at all. That's kind of weird. And the other thing is, if I start figuring out my slope, okay, again, I'll start here and go up. So my rise is 2, but then notice my run, I don't have to go anywhere, is 0. So again, I'm stuck in undefined. Okay, so this is really what we had before. I've got undefined, so oh man, I have to figure this out. But I do know it's going to be x equals some number. Okay, well, look at where all these guys are. Negative 8, 0, negative 8, 2, negative 8, 4. Common theme there was the x value is negative 8. So there's your equation there. Again, not much work you can do for that one, so you do have to have certain things memorized so that you can get an answer when you need it. Alright, now on to the try these. Okay, write the equation of each line. And there's 2 others that are based off of graphs. Alright, hopefully that made sense. I'll see you in class.